Okay, hey guys. For those of you that missed the introduction to trigonometry, here it is, okay? Trigonometry comes down to three ratios. And we're going to be dealing with just right angle triangles, so triangles that have a right angle in them, okay? And those three angles are, let's get rid of this here, sine, or we use the words sine, sin, okay? We've got cosine, which we use cos for short, C-O-S, and we have tangent, which I think you spell like this, I don't know, which we use T-A-N, okay? So when we are dealing with a right angle triangle, okay, like this, for example, where we have our right angle, the right angle is always pointing at the hypotenuse, okay? And so say we have so we don't know this angle, we don't know this angle. We know that all the angles in a right angle triangle add up to 180. And if we already know that this is 90 degrees, well, we know that this angle and this angle have to add up to 90 degrees, okay? So say I have an unknown angle. Now in trigonometry, most of the time we call our unknown angles, they're called theta. That's what we call our unknown angle. Just like an unknown side is x or y, an unknown angle is theta. So if we have an unknown angle theta, and say I know that this is going to be the opposite side to that angle, okay? And this is going to be what we call adjacent side. So the opposite side is opposite the angle, and the adjacent side is the side that's touching the angle, but that's not the hypotenuse, okay? So for sine, we say sine of our unknown angle, the ratio is equal to the opposite side over the hypotenuse, okay? So say I knew that this was say 10, and I knew that the hypotenuse was 12 centimeters, for example, then sine of my unknown angle, theta, would be equal to 10 divided by 12, okay? That's for this angle here. Now, if I was dealing with another angle, say angle B here, well then now, according to this angle, this is the opposite side, and then this would be the adjacent side, okay? Because now for angle B, so sine, we would say sine of angle B would be, say this is 10 now, or this is, say 7. Sine of angle B would be 7 divided by the hypotenuse 12, okay? For angle B. Cosine. So same thing. So say we have a right angle triangle, okay? This one looks a little different, but it's kind of the same. Again, we're going to have our right angle, which is pointing at the hypotenuse. Hypotenuse. And then same thing, this angle and this angle add up to 90. So say I'm working with this angle. I don't know what this angle is, okay? Again, this is going to be the adjacent side to that angle, which means it's touching the angle, but it's not the hypotenuse, it's adjacent. And then this is going to be the opposite, okay? Now say, for this angle, I would say that cos of that angle, theta, is equal to the adjacent side over the hypotenuse, okay? So if I knew that this was, let's say 6, and I knew this was 10, cos of this angle would be equal to 6 over 10, okay? Or if I knew that these sides, we called them x, y, and z, for example, in this one, and say I did, okay, this is my angle B. Well, the cos of that angle B...
Excuse the interruption. Brenton, Sampson, come to the office, please. Brenton.
Cos of this angle B is going to be the adjacent side, which is now this side, so it's touching the angle and it's not the hypotenuse. So it will be Z divided by the hypotenuse, which is X. That would be the ratio, okay? And then finally, we have our tangent ratio, okay? And the tangent ratio does not care about the hypotenuse. It does not care about the hypotenuse. Well, it does, but you'll see. So we have our right angle, which points at the hypotenuse, and say I have my angle theta, I have my opposite side to that angle, and then I have my adjacent side to that angle. Adjacent is the same, it's touching the angle, but it's not the hypotenuse. Well, tan of this angle, theta, is equal to the opposite side over the adjacent. Okay, so these three, this guy, and this guy, these three ratios, these are our three trigonometric ratios. And this is what all trigonometry essentially comes down to, at least for now. Okay? So say I knew that this was X, this was Y, and this was Z. And say I said, okay, angle B here. Tan of that angle B would be the opposite, which is X, over the adjacent. The adjacent's not Z, because that's the hypotenuse. The adjacent is going to be Y, so it would be X over Y. Same thing, so if I said tan of this, the original angle, just angle, not angle B, but just the angle theta, tan of theta would be the opposite, which now is Y, over the adjacent. And again, the adjacent can never be the hypotenuse, it has to be the angle, or the side touching the angle. So it'd be X, Y over X, okay? So this just is the beginning, the kind of the building blocks from which or the foundation for trigonometry. So we're gonna now see how we can use these to solve for different things in a triangle. Perfect, that's it.